Hi, everybody, and welcome to another episode of Ok Xoomer Zoom interviews with creative engineers and more. I'm your host, Aaron Lichtig, Xometry Guy and former Jeopardy champion, and I'm excited to be here today with Dr. Sharon Flank. Now, Dr. Flank is a recognized expert in anti-counterfeiting across several industries. There were some fascinating examples that we'll talk through today, and a leader in IP protection for additive manufacturing, 3D printing. She has a decade of experience creating AI solutions on the emerging technology team at a defense contractor, followed by some entrepreneurial experience, and then she founded her company, InfraTrac, in 2006. So Sharon, welcome. It's great to have you.
Great to be here, wherever here may be at the moment.
Excellent. So tell us first about InfraTrac and what motivated you to start the company.
I was looking for some AI applications actually in biotech, and I heard a presentation by a University of Maryland professor of pharmacy talking about an inventive way to tag and track drugs using spectroscopy. And I thought that I could give him some advice and pointers and get a finder's fee if I hooked him up with a venture investor team that I knew, and the venture investor team asked if I was interested in founding a company with their backing, and to my surprise I said yes.
Excellent. So you work across a wide variety of industries, and before we get into additive manufacturing, I had to ask, on your website it says you once identified vodka mixed with goat urine masquerading as Chanel No. 5.
So first, counterfeiting is a big problem across a whole lot of industries, and anything that you can make really cheaply and slap somebody else's brand name onto, you can make more money out of. So Chanel No. 5 sells for a whole lot more than vodka and goat urine, and Chanel No. 5's odor, pleasant odor, lasts longer, but you can kind of mimic it for just long enough to sell it with a horrible combination of materials. And one of the things that we use even now to detect counterfeits is a handheld spectrometer, an object as little as this one, that can tell the difference between goat urine and vodka versus Chanel No. 5, but also polymers too.
Excellent. So now switching to additive manufacturing, how do you and how does your technology determine whether or not something that's 3D printed is a counterfeit?
You could print a barcode onto it, but a bad guy with a 3D scanner could print the same barcode onto his bad copy. So that's not a great idea. You could put RFID chips into absolutely everything, but those can be hacked, and also you don't want to spend the money and time to put them into everything. Or you could sprinkle some stuff, and if it's very special stuff, then you have to worry about the supply chain. Instead, what InfraTrac does is we take compatible materials, we print them in, so it's during printing, and then we create, you can probably just see if I hold this up to the light, that there's a little tiny square that you can just detect subsurface, and with a spectrometer and a whole bunch of smart modeling from my team, or a licensed model, you can detect, well, it's not real unless it has the tagant in it. And so that method of covert chemical tagging is what we license.
Gotcha. Now, where in your time in additive manufacturing, where have you seen this technology go? What types of products?
We spent a year or two ahead of the market where everybody said, well, we only ever make one at a time and we always watch the printer, but eventually we'll make more, won't we? And then suddenly 3D printing gave way to additive manufacturing, and everybody started to think about, oh, distributed manufacturing means sometimes we make especially spare parts near where the thing breaks, and we trust other people to supply us with reliable branded material that at least our reputation and sometimes somebody's life depends on. And at that moment, it became clear that, wait, we're going to need to do something. And that something is now being embraced by the standard and obvious early adopters of additive manufacturing. So defense and aerospace first, because lightweighting is important to them. Automotive is just beginning. big machinery of various types, and then medical devices comes next after that, because anything that matters enough to protect.
Hmm. That's a great way of putting it. Now, what advice would you have for someone who wants to do what you've done, taken some of your knowledge and then started a really interesting company with it?
One of the most fun things about innovating in a new industry is that it's full of other people tackling exciting new arenas at the same time, and everybody's curious and excited. And so we may not immediately have had, for example, applications in biotech for 3D printing, but we're certainly keeping track of what the 3D printable, body compatible types of materials are, and we have expertise coming into this from drug manufacturing, so we expect that there will be applications in 3D printed, probably customized, personalized medicine drugs printed in pharmacies. So keeping an eye on innovation, keeping up, making sure that your team is kept up, keeps everybody excited and happy to be at work, but also gets you ready to pounce when you draw in ideas from related areas and you say, well, we haven't been checking quality this way, but welding does, and you know what? That stuff from welding actually applies over here if you tweak it in these ways.
Excellent. Well, Dr. Sharon Flank, thank you very much for joining us today on Ok Zoomer. It's been great talking with you. And hopefully next time I buy Chanel #5, it won't actually be vodka mixed with goat urine. But we really appreciate having you on the show today.
It's been my pleasure. Thank you.
Thank you very much. This has been another episode of Ok Zoomer. Please join us again in a couple of days when we will issue another one. Take care.